Today we are going to see ANOVA problems. Setup. ANOVA table. For the following per hectare yield, for 3 varieties of wheat. Each grow in 4 plots. Per hectare yield 100 grams. Plots of land, variety of wheat. A1, A2 and A3. Plot of land 1, 6, 5, 5. Land 2, 7, 5, 4, 3, 3, 3, 3, 4, 8, 7, 4. Also work out F ratio and test whether there is significant difference among the average yield in the 3 varieties of wheat. Solution. First fix null hypothesis. H0 is mu1 equal to mu2 equal to mu3. That means the average yield of 3 varieties of wheats are the same. The alternative hypothesis mu1 not equal to mu2 not equal to mu3. Not same. First let us apply F test to test the above hypothesis. X1, X2, X3, 6, 7, 3, 8, 5, 4, 3, 5, 5, 3. Five, 3, 7, X3, 5, 4, 3, 4. We have to find out x1 squared, x2 squared and x3 squared. X1 squared 36, 49, 9, 64. X2 squared 25, 25, 9, 49. X3 squared 25, 16, 9, 16. Now find total value. This 24, 20, 16. This value is 158, 108, 66. Now n is equal to number of observations. So here number of observation is 12. 1, 2, 3, 4. 4 observation from x1. Similarly, 4 observation from x2 and x3. So total 12. T is equal to total of all the observations, that is equal to 24 plus 20 plus 16, that is equal to 60. This 24, 20, 16. Then find correction factor t squared by n, that is equal to correction factor, that is equal to 60 squared by n, 12. Use calculator, we can get 300. Next find total sum of square, total sum of square, that is equal to summation of x1 squared plus summation of x2 squared plus summation of x3 squared minus t squared by n. So summation of x1 squared 158 plus 158 plus 108 plus 66 minus 300, that is equal to 32. Next find SSC, this one is SST, total sum. Next column, sum of square, this summation of x1 the whole squared by n1 plus summation of x2 the whole squared by n1 plus summation of x3 the whole squared by n1 minus t squared by n. That is equal to summation of x, that is 24 the whole squared by n1, number of terms in column. So here this one is 24, number of 1, 2, 3, 4. So n1 is 24, n1 is 4 plus x2 20 the whole squared by 4 plus 16 the whole squared by 4 minus 300. Is the calculator, that value is 8. So therefore SSE, that is error within column, SST minus SSC, because SST equal to addition of SSC plus SSC. So this value is 32 minus 8, that is 24. Now fix this value in ANOVA table. Source of variation, sum of squares degrees of freedom mean sum of square and variation ratio. Between column and within column, otherwise this one we can say error. Sum of squares already we found. SSE error is 24. Degrees of freedom, this value is 2, this value is 9, so total 11. Mean sum of squares, that is equal to SSE by 2, that value is 4. Mean sum within column SSE by 9, that is equal to 24 by 9. Ratio FC equal to 4 into 9 by 24, that value is 1.5. Plus degrees of freedom, this one is 3 varieties, so 3 minus 1. The test, so we can write SST equal to 32. Total degrees of freedom 11, because total number is 12. 12 minus 1, 11. The test statistics is FC equal to MSC by MSC. Mean sum of squares divided by mean sum of error, that is equal to 1.5. Number of degrees of freedom, number of 2,9. The table value of F at 5% level is 4.26. The conclusion H0 is accepted. H0 is accepted at 5% level of significance, since the calculated value of F is less than the table value of F. Therefore, there is no significant difference among the mean. Difference among the mean. In example 2, in perform a two-way classification ANOVA on the data given. the data given below. Treatment treatment 2, here treatment 1, one, 2, 3 treatment, here 1, 2, 3, 4 and 5, corresponding value 1, 1, that is 30, 2, 1, 24, 33, 36, 27, 26, 29, 24, 31, 35, 38, 28, 35, 30, 33. Use the coding method subtracting 30 from the given number. Directly we can use these numbers. Coding method means the big numbers converted to very small numbers, and it is very easy to calculate. Solution. First write hypothesis. There is no significant difference between column means as well as between row means. H1, the alternative hypothesis, there is significant difference between column means as well as between row means. The value of f is unaffected by subtracting 30 from all the numbers. So x1, x1, x2, x3. This treatment 1, treatment 2, y1, y2, y3, y4 and y5. So fix the value. Subtract from 30 minus 30, that value is 0. This minus 6, 24 minus 30, 33 minus 30 and 6 minus 3, x2 minus 4 minus 1 minus 6, 1, 5, x3 8 minus 2, 5, 0, 33 minus 33. Next, find total, because we need two-way classification. Total, this value is 4 minus 9, 2, 7 and 5. Next, find x1 squared, x2 squared, x3 squared. x1 squared 0, 36, 9, 36, 3, x2 squared 16, 1, 36, 1, 25, x3 squared 64, 4, 25, 0, 9. So total, this value is 0, this value is minus 5, this value is 14, this one is 9, 90, 79, 102. Next find capital N. N is equal to 5 plus 5 plus 5 equal to 15. Capital T equal to this value is 0 minus 5 plus 14. That is equal to 9. And correction factor T squared by N. So 9 squared by 15. That value is 5.4. Then total sum of square, that is summation of x1 squared plus summation of x2 squared, x3 squared minus t squared by n, that is 90 plus 79 plus 102 minus 5.4 correction factor, that value is 265.5. Now sum of squares column, summation x1 the whole squared by n1 plus summation of x2 the whole squared by n1 plus summation of x3 the whole squared by n1 minus t squared by n. That value is 0 squared by 5 plus minus 5 the whole squared by 5 plus 14 squared by 5 minus 5.4. So that is equal to 38.8. Now we need to find sum of square in row wise. Row wise, summation of y1, summation of y1 the whole squared by, this value is 3 treatment 3, plus summation of y2 the whole squared by 3 plus summation of y3 the whole squared by 3, y4 the whole squared by 3 plus summation of y5 the whole squared by 3 minus t squared by n. y1, y2, y3 is total value. This total value that is y1, y2, y3, y4, y5. So 4 squared by 3 plus 9 squared by 3 plus 2 squared by 3 plus 7 squared by 3 plus 5 squared by 3 minus 5.4, that is equal to 52.92. Now draw the ANOVA table. Source of variation, sum of squares, degrees of freedom, mean sum of square, variation ratio. Here between columns, then between rows, and error. Between column 38.8, between rows 52.92, so this value actually 173.78. Degrees of freedom 2, 4, 8. Total 14. This total 265.5. See 38.8 by 2, 19.4. This value 52.92 by this 4, 13.23. 173.78 by 8, that is 21.72. So ratio FC, see which is greater value 21 points. So 21.72 by 19.4, that value is 1.12. Row wise 21.72 by 13.23, that value is 1.64. The test statistics, F test in column wise, that is 1.12. F row wise, C by MSR row wise 1.64. The number of between degrees of freedom between columns 8, 2, degrees of freedom between rows 8, 4. So table value F for 8, 2 degrees of freedom at 5% level is 19.4. Table value of F for 8, 4 degrees of freedom at 5% level of significance is 6.04. So conclusion, in both case calculated value of F is less than the table value of X. Therefore, H0 is accepted at 5% level of significance, and hence there is no significant difference between the means due to treatment 1 or treatment 2.